Hello friends, so this is another question on signal flow graphs where we have to find out the transfer function using Mason's gain formula. Okay, so we have to find the transfer function. So here uh, in order to go with the the Mason's gain formula approach, we have to find out some parameters associated to forward path gains, loop gains, path factors, and then we will proceed. So first the forward paths. Okay, the forward paths. Okay, so here in this SFG signal flow graph, one of the forward paths which you can see is this R1, 2, 3, 4, 5, C. Okay, R1, 2, 3, 4, 5, C. That is one forward path, and the gain is G1, G3, G4. Okay, G1, G3, G4. That is the first forward path. The second forward path is this R1, 2, then directly from 2 to 5 along this directed path, 2 to 5, this branch, 2 to 5, then C. So P2 is R1, 2, 5, and C. Okay, and the gain is minus G1, G2. G1, G2. Okay, minus G1, G2. So these are the two forward paths. Now the loops. Okay, so the two forward paths we have determined. Now the loops. Okay, one of the loops here is loops are basically which start and end at the same node. Okay, so one of the loops is 3, 4, 5, and again back to 3. Loop L1, 3, 4, 5, 3, and the gain is minus G3, G4. Okay, then another loop is, pay attention here, 1, 2, 3, 4, then 1. Okay, 1, 2, 3, 4 along this path to 1. 1, 2, 3, 4, then 1, and the gain is minus G1, G3, H1. Another interesting thing again here, see here at this point, this path or this loop, it splits into two separate, okay, with the gain of the branches equal to minus 1. So there will be another loop also with the same thing, 1, 2, 3, 4, 1. See, 1, 2, 3, 4 up to this point, it is for this directed branch, and again for this directed branch. There are two branches here with same gains, so there will be same things with same gain values, loop gain values, minus G1, G3, H1. Okay, so three loops we have identified. Next, the fourth loop. Okay, again please watch this very carefully. 1, 2, 5. Okay, 1 to 2, then from 2 to 5, okay, then from 5 to 3, then from 3 to 4, then from 4 to 1, okay. Again see it, 1 to 2, 2 to 5, 5 to 3, 3 to 4, 4 to 1. Again it will be two kinds, one along this path, one along this path, because there are two similar branches from this point, okay. So please, as I'm saying the loop nodal paths, you write it also in rough, so you practice it so that you get an idea how the loops we are identifying, forward paths, loops, wherever you have some doubt, practice it in rough. Again I'm repeating it, this loop is a bit complicated. 1 to 2, 2 to 5, 5 to 3, 3 to 4, 4 to 1, and it will be two loops, similar loops for this splitted path with equal gains. So L4 is 1 to 2 to 5 to 3 to 4 to 1, and the gain is minus G1, G2, G3, H1, okay, minus G1, G2, G3, H1. Again there will be L5, which will be the same thing, 1, 2, 5, 3, 4, 1, and again the gain will be minus G1, G2, G3, H1. So now we have to find out the path factors and if there are any touching or non-touching loops here. So path factor is, we all know, we have to see whether the particular forward path is touching the loop or not. So the best way to find out is to see whether there is any common node in between them, okay. So see, for path P1, R1, 2, 3, 4, 5, see here 3 is common, 3 is there. Here also 3 is common, 3 is there. 3 is common in L3, 3 is common in L4, 3 is common in L5. So as I've already said, you just have to find out that one common node. You don't have to find more than one common node. So if you find only one common node is there, it means it is touching. No need to waste any more time. So P1 is touching all the loops. So the path factor for P1 is 1 minus 0, which is equal to 1. It is 1 minus sum of the loop gains of the loops which the path has not touched. As it is touching all the loops, so it is 0, it is 1 minus 0, 1. For P2, see 1, R1, 2, 5, C. In L1, it is common, 5 is common in L1. In L2, 2 is common. In L3, 2 is common. In L4, 2 is common. In L5 also 2 is common. So here also it is touching all the loops. So the path factor is delta 2 minus 0 equals to 1. Now touching and non-touching loops. We have to find out whether there are any loops which have no node in common, that is they are not touching each other. Again, common nodes we have to find out. L1, 3 is common, then 3 is common, 3 is common, 3. So see, 3 is the common node in all of the loops. So it means all the loops, they are touching each other. So you just have to find out that one. There are also other common nodes, but you pick the first thing which is we can spot. Okay, if there is only one common node also, no need to waste any more time. It means that the loops are touching each other. So no 2 or 3 non-touching loops. So we have found out all the parameters: forward path gains, loop gains, path factors. Now we have to put the values in Mason's gain formula equation. So we have found out all the parameters required for Mason's gain formula equation. So according to Mason's gain formula, okay, the transfer function of the signal flow graph, it is given by Okay, the summation of the product of the forward path gains and the path factors divided by the graph determinant. So here the graph determinant, as there are no any non-touching loops, so it will be simply 1 minus sum of the individual loop gains, and it will be 2 path factors and 2 forward path gains, because there are only 2 forward paths. So this whole equation, it will get modified as 2, 3, 4, L5. Okay, this. So if we substitute the values, it will be G1, G3, G4 applied with 1, then minus G1, G2 applied with 1, then it is 1 minus G3, G4, G1, G3, H1 minus G1, G3, H1, G1, G2, G3, H1, then again minus G1, G2, G3, H1. So when we open the bracket, it will all become plus. This is the whole transfer function for this signal flow graph here.